Hi guys, Buildzoid here, and today we're going to be taking a look at a very silly memory overclock, what I would consider a novelty memory overclock, because realistically you wouldn't ever really want to do this, but it's kind of cool that it works. So, the memory that I have in the system right now is this stuff right here. So this is some old Corsair Dominator Special Edition memory. This is from the X99 era, and its version, come on, focus, it's version 4.24. Version 4.24 stands for Samsung 4 gigabit eDie memory, and that stuff is no longer in production. It's the predecessor of Samsung BDie, and unlike Samsung BDie and basically most other DDR4 memory chips, this stuff just does not care, and I love it for that. And when I say it just does not care, what I mean by that is this is memtest, tested out to 600% at, where is it? 2 volts. Yeah, 2 volts. We're also running 3600 CL12, and this is a dual rank setup, so it's four 4 gigabyte memory sticks. So we've got 16 gigs of RAM in total, so, you know, a bit low for a daily system. Like, yeah, I'd say a bit low for a daily system today, but it's workable. Right? Like, as long as you're not like me and keep forgetting to close stuff, 16 gigs of RAM is plenty of RAM. Or you don't play super heavily modded Minecraft. That's actually one of the main reasons I have 32 gigs of RAM. It's Minecraft. So, yeah. Anyway, but yeah, so this just finished like 600% stress test pass. It's at 2 volts. There is a fan on the memory, and the room is currently at around 25 degrees Celsius ambient. And that fan is enough to just keep the memory sticks at, well, scroll down. So the outer two memory sticks, like one of those is at the outer two memory sticks are at 42 degrees, and then the inner two are at 45 because, well, they're sandwiched in between the other two DIMMs, so they get a lot less airflow. But yeah, so, you know, I'm actually not even sure that the temperature needs to be kept this low. Though basically every memory chip is temperature sensitive to some extent, so I'm not too interested in finding out what would happen if I remove the fan. But yeah, so it does run Linpack. It does run memtest. It does not run Linpack fully stable, though I don't think that's the fault of the memory sticks, because when I first started messing around, like, the thing is, you'll notice that I'm on air cooling here, and we are on the Gigabyte Z590 Master motherboard. I was supposed to be testing a different kit of memory, and then I was like, you know what? I'm sick and tired of 8 gig Samsung memory chips, or, well, not really, not just 8 gig memory chips in general. I just want to mess with something, you know, wacky and weird, and something where it's super easy to work with, which eDie is. As you can see, it just did 600% mem test at 3600 CL12. If you were insane, or, like, here's the thing, I would not daily this unless I had a spare CPU. Like, I've not yet seen a DDR4 memory controller actually die from memory voltage. But at the same time, I wouldn't really use my memory system to validate if that is actually the case, unless I had a spare CPU. Yeah, but the cool thing with eDie here is that, compared to other memory chips out there, this is actually stable, because you might be like, why wouldn't you do this on Samsung BDie? Well, on Samsung BDie, if you try to run this much voltage, it gets horribly unstable unless you disable most of your memory capacity. So we're obviously not doing that, and I should really get Linpack up and running. So 4. Actually, let's punch in 10. It probably won't even make it to 10. Yes, yes, no. But it should be stable enough to give us a performance metric, like a performance measurement. But not stable enough to, not stable enough to survive. And the thing is, basically when I first started testing this memory setup, I was having Linpack stability issues, even with, like, auto subtimings, because dual rank already gives you so much memory throughput. And also, these are 4 gigabit memory chips. So 4 gigabit memory chips, for those of you who don't know, actually come with tighter timing specifications than higher capacity memory chips like 8 gigabit or 16 gigabit. So on auto settings, these actually like run a bit more, like run faster than your 8 gigabit and your 16 gigabit chips. Not by a huge amount, but a little bit faster. And so basically, this right from the get-go wasn't stable. As in, I couldn't even finish a single loop of Linpack until I fiddled with the LLC so that the CPU would get more voltage. Because I think the Gigabyte motherboard here is just, like, the chip is running so hot that it's, like, what is it? Isn't the thermal It's not thermal velocity boost. That's the thing that drops the CPU to 4.7. Basically, the CPU air cooling, I think, is just leading, like, that I think is crashing Linpack. Because raising the voltage improved Linpack stability, and by that I mean raising core voltage. Not memory voltage, not memory controller voltage, none of those things really did anything. It was just raise core voltage, and Linpack got more stable. So I'm inclined to believe that basically if, like, I should have been running this on water cooling instead of air cooling. So... yeah, and the CPU is at stock, and like the air cooler really just it's an 11900K. I think if this was a like, I kind of wish I did this with like an 11600K. That might have made it make slightly more sense because, you know, you can get these old Samsung eDie based kits quite cheaply on eBay and stuff, and then pair them with an 11600KF is not that bad an idea. I say KF because I don't know why you'd want to pay extra for an iGPU you're never going to use, but because in my opinion, like, I've heard people say, oh, the iGPU is useful when your main GPU dies, and my solution to that is, like, just have a spare GPU. Like, if you're building computers for long enough, you should have spare GPUs, in my opinion. At least one. Because, like, GPUs and motherboards are, like, the top two things most likely to die in a system, in my opinion, so... or in my opinion / my experience, it's like motherboards and GPUs die. Things that don't die are like CPUs and memory sticks. Those two things generally survive everything. And then everything that, like, any larger printed circuit board needs to have backups. So, anyway, yeah, so this would kind of make sense if you were running it as, like, a high-performance budget memory setup. The G-flops are a bit low, and that's because the CPU is all the way down at 4.7 gigahertz, because it is running very, very hot. It's not thermal throttling, but, you know, barely not thermal throttling. The air cooling is really not ideal for this. But yeah, I didn't feel like pulling out the water cooler just for the sake of being able to run Linpack, so this will almost certainly eventually crash because the CPU is just barely capable of running it as is, which... yeah, if you're wondering about, like, shouldn't this be stable since we're at stock settings, technically Intel would validate the CPU for Linpack stability at JEDEC. And JEDEC is 3200 CL20 or 22 or something horrible like that. It is not 3600 CL12. And the performance is pretty good, right? For 4.7 gigahertz, this is roughly what you'd expect. So we're not memory bottlenecked at this point in Linpack. It's just the CPU's not going that fast. And now let's run some IDA, which IDA actually looks really terrible on this memory setup because the frequency is kind of low. We are in Gear 1 and we are in, like, true 1T command rate. Yeah, and also I'm not sure if IDA will actually run properly. It sometimes bugs out and spits out 0, and then you need to restart the system to fix that. Oh, actually it did manage to thermal throttle this time around. Oh well. Yeah, so that's the main issue with trying to run Linpack on this setup right here, is just, like, the air cooler was a bad idea. I was too lazy to, like, this thing with AIOs, you need to, like, bolt them down because they won't just sit there with gravity. Like, that air cooler is literally just sitting there, so... yeah, anyway. For 3600, this is actually decent bandwidth because the theoretical maximum, we'll get to that once it runs, and latencies floats around a bit, and I think it mostly floats around because of the ring clock going up and down kind of randomly, but anyway, theoretical max bandwidth is our megabits per second multiplied by 8 bits per... well... now we're going to do it this way. Multiply by 128, divide by 8. Yeah, so theoretical max memory bandwidth is 57 gigabytes per second at 3600 megabits per second. because it's a dual channel memory controller. Each memory channel is 64 bits wide. And this is why I like megabits per second, because your bandwidth measurements then start making sense. But you'll notice that IDA is actually reporting a read speed that is physically impossible. And that's just because the IDA memory test is not that great. I've actually seen, like, I've seen a screenshot from somebody where they intentionally ran memory settings that really bug out the IDA memory test. And then they had like a read speed that was like tens of % above theoretical maximum for the memory configuration they were running. And yeah, so, and the thing is, like, this is a problem with just memory tests in general, is, like, unless you're, like, if you're trying to synthetically measure the memory bandwidth, it's really hard to prevent the measurement from, like, spilling into the L3 cache or something. And that's the main issue with this kind of thing, is, like, making sure that the CPU does exactly what you tell it is very difficult. So, like, yeah, that's why that read speed is actually... Like that read speed measurement is physically not possible. We cannot be doing 57.7 gigabytes per second at 3600 megabits per second. Like, I've seen better latency numbers, so that's why I'm running that. And we should also run the TimeSpy CPU test, just because I like that as a... Like, Linpack is insanely hot, so TimeSpy CPU test is a nice memory benchmark that doesn't try to murder your murder your CPU and memory controller in the process. But of course, that's what makes Linpack such a great stress test, is that it murders your memory controller and your CPU. So that's kind of why I like using it as a stress test, but then it's like when you decide to half-ass your CPU cooling, yeah, Linpack gets upset about it. Like, that heatsink is not attached to the CPU. It's just sitting there. I'm not even sure how much thermal paste is under it. It's probably really bad. I should have probably closed a lot of the stuff that's in the background, because this unfortunately, like, a lot of memory tests are pretty sensitive to stuff being open. So this is maybe going to be kind of bad. Oh, actually, this is the best run I've gotten out of this yet. So, yeah, I did tighten up the tertiary timing since the first time I got this idea, and I stabilized one set of 3600 CL12, and I was like, oh, that was cool. And then I was like, what if I made the timings better? So this is actually, like, this is approaching the same level of performance that I was getting out of, like, Gear 2 overclocks pushing much higher memory speeds. So, yeah, like, this is a really good result. I'm actually surprised that we could get that right now. And I guess let's run Geekbench. You know, the thing is, like, yes, Geekbench has the same problem as IDA in terms of measuring memory performance, where it's just not very sensitive to certain timings. And it's more of a, like, it's a very theoretical memory bandwidth test rather than, like, a usable memory bandwidth test, but it's a nice short benchmark, and, you know, it gets points on hardware bought. That's basically all that determines if I like a benchmark or not. So, come on. And ta-da! We get almost 9,000 points, which for the speed we're at is really not bad, because again, this is, like IDA, a very much a raw bandwidth test rather than usable memory throughput test. Right, I have a video showing how, like, technically you can run IDA and Geekbench with settings that are actually terrible in terms of real world performance, but both Geekbench and IDA won't really pick up on that because they're very much just like frequency trumps all, and that's kind of all they care about. So anyway, here we are in the BIOS. This is a little bit too high on the VCCIO. I'm not sure if it wouldn't work at 1.45 volts, but already, like, the thing is, these DIMMs, these Corsair Samsung eDie DIMMs, they're old. They use the A0 PCB, and the A0 PCB is not ideal. As far as, yeah, it's not ideal. Like, there's a reason it got replaced by A1 and then A2 eventually, as just optimization in the design of memory PCBs to be better and better. Mainly in terms of, I'm actually not sure what the like design goals were for the later PCB revisions, but well, you really notice it on frequency. Like A0 generally has a frequency wall somewhere around 4600 megabits per second, uh, which doesn't make sense to say frequency, but like a speed wall at around 4600 megabits per second. Um, and A2 doesn't. Like A2 will go well past 5000 megabits per second if your memory controller is good enough. But anyway, so yeah, the VCCIO2 is I wouldn't want to like I'm more concerned about that 1.5 volts of VCCIO than I am about the 2 volts of memory voltage, because this is Samsung eDie. This stuff just does not care. It's great. I love it. Like, it's so easy to stabilize. It's like, oh, it's not stable. Just throw more voltage at it and make sure you have airflow, right? Because if it does get too hot, then you will have problems. And here we have the timing. So yeah, cast latency of 12 at 3600 megabits per second. And if I had more voltage range, like, I'm kind of annoyed that I chose, well, if I had more voltage range, if we could go up to 2.1, I'm pretty sure I could get this to run 3600 CL11, but we can't because the motherboard only goes up to 2 volts. How very sensible of Gigabyte. So, anyway, but we're at 12, 19, 19, 19, 28, and I did, like, theoretically, these DIMMs should be able to do, like, 37, 33 at CL12, but because this is dual rank, the memory controller gets rather upset when I try to do that. And we would need, like, a hell of a lot more VCCIO and VCCSA, and, yeah, I am not doing that. And when I say VCCIO, I mean VCCIO2. That's a really stupid voltage name. I guess I should call it just IO2 voltage. Yeah, for short, just IO2 voltage. So yeah, we'd need a lot more IO2 voltage because, yeah, like in Gear 1, like 37, 33, depending on your CPU, of course, right, because Silicon Lottery, but a lot of the time at 37, 33, you need a lot of system agent and IO2 voltage. Like, in Gear 2, this much voltage would be good for, like, over 4600 megabits per second. And here it's like we need this for 3600, which is really quite annoying. I've raised the VCC VTT a little bit. This can sometimes help with memory overclocking a bit, but I'm not, like, I didn't do an A/B test here, and it's not high enough to cause any concerns, so that's kind of just there. Advanced voltage settings, I have the termination drop to 0.916. This is not necessary. Samsung eDie really doesn't care. When I was trying to get CL11 to work, I was like, oh, let's do the BDie thing of just drop the termination, because that usually will help you. Like on Samsung BDie, that would be really critical for stability at these higher voltages. Samsung eDie does just, no, it doesn't make a difference. But the thing is, like, since it doesn't make a difference, I just kind of left it there. And then ring PLL is offset by 60 millivolts, and that can sometimes help with memory stability, especially if you're, well, yeah, this can just generally help with memory stability to run a slight ring PLL offset. It depends on the CPU. Not all CPUs will care, but at the same time, it's such a small voltage increase that there's probably no harm in just, there's no harm in testing it out. It might cause some CPUs to get unstable, maybe, but in my experience, it basically does, either it does nothing or it helps. And so, you know, no reason not to add that 60 millivolt offset there. Anyway, timings. So yeah, 12, 19, 19, 28, TRC. What's neat about Gigabyte's Z590 BIOS is they're one of the few motherboard manufacturers that give you access to the TRC timing. So that's nice of them. I'm not sure if it actually makes a difference. I might have to dig through the Intel documentation whether that register even exists, but it should. And so it's kind of neat that, it's neat that it's available, assuming that it's actually doing anything. Then TWR10, I don't think you can set it. Oh, wait, no, you can set it lower. Oh, man, I should have tested like 8 or something then, because that might actually work. Anyway, TCWL10, TRRDS and TRRDL of 4, 4.4. 4 active window is at 16 because that's for max performance. RTP at 8. That might do 6, but I didn't feel like testing that. It doesn't really make too much of a performance difference either. TCCD, SNL are at 4 and 7. Not all BIOSes give you access to these. And 4 and 6 doesn't work at this frequency, well, in this memory configuration. TRFC at 277. It might actually, the interesting thing about EDI is it actually does worse TRFC than BDI, which is super weird because theoretically, like, if you go with the assumptions that the JEDEC memory specifications make, 8 gigabit memory chips should universally have weaker TRFC than 4 gigabit memory chips. BDI doesn't. BDI does lower TRFC than EDI does. So yeah, this is a 277 at 3600. If you were on like a good kit of BDI, you might be able to run like TRFC of 222 or 233 or like really low, like a couple tens of ticks lower. So yeah, like it's not a huge difference in terms of performance. It's just an interesting thing that like EDI does actually tend to need slightly higher TRFCs than what you would expect from say BDI kits. And then command rate of 1, which is really cool that like 1T command rate works on a dual rank memory setup. Because a lot of at the same time, we are at really low frequency, so it's not super surprising. But yeah, that's neat. That certainly helps performance quite a bit. TREFI is at 65,000. TXP is at 4. That helps with memory latency a little bit. And then down here, I forgot to set the TCKE to 4, which would just doesn't make too much of a performance difference, but yeah, I forgot about that one. And then for the tertiaries, we've got 6, 4, 6, 6. I tried 6, 4, 5, 5. That doesn't boot. Also, I don't need to use the DR timings because DR stands for different rank. And technically, and you might be like, but isn't this a dual rank setup? Well, yes, but the second rank is located on a different DIMM. So we don't use the different rank timing, we use the different DIMM timing. So like this is actually like, that would boot. It wouldn't do anything because we don't actually have a different rank. Like that timing refers specifically to a different rank on the same memory stick, but we've got 4 different memory sticks. So that timing doesn't apply in this scenario, but it's more visually appealing if you have 6466 in my opinion than like 6416. And yeah, like basically under any, in my experience, you should be able to run your DR and DD timings at the same value, basically always. So it's like, yeah, I just set them at the same time like they're the same thing, even though they aren't. Then we've got the RDWRs, which are all just set to 12. Then we have got the right-to-right timings, which are again just 6466. And then we've got the TWRD, like right-to-read, same group and different group. These are at 29 and 25. This is another weakness of EDI compared to Samsung BDI, is you can't run the right-to-read timings as tight as you can on Samsung BDI. So yeah, these are a bit loose. There might still be some headroom in them, but last time I said there would be more headroom in these 2 timings. I tried, like in a previous video, there's another memory overclocking video that I posted where I was like, yeah, you could totally lower these. And then I tested it. No, you couldn't. They were already maxed out when I shot the video, and I just hadn't, like, so yeah, like, I think those are also maxed out at this point. There might be maybe a little bit more headroom, but I doubt it. So yeah, that's the timings, and then all of these settings down here are just left on auto. The board seems to do a good job of setting them on its own, at least for 3600 megabits per second. So I'm pretty happy to just let the board do that on its own. And then we've got, I did also raise the LLC from the auto setting to low because Linpack was crashing when it was set to auto. It's still crashing eventually, so it's still evidently not enough voltage, but the air cooler is not thrilled about the fact that I have it on an 11900K, and I'm trying to run Linpack with, close to, like, in hardware info, it was reading like 220 watts of CPU power draw. The air cooler is very upset about that. So yeah, we're not gonna, like, I'm not gonna raise the voltage any higher, and that's it. Like, that's all I've really changed here. Oh wait, no, there is one thing. If you've got a Z590 Gigabyte motherboard that's like the Z590 Ultra or the Master or the Extreme, there's one feature that makes these boards super, like, way nicer to work with than Gigabyte's older Z490 boards, and that's this right here. You can set the reset button to act as a safe mode button, which, yeah, has saved me a bunch of time when setting up this overclock. It's actually the main reason why I ultimately decided to why the Z590 Master is currently on, like, the test bench that I'm using here, is because I wanted a motherboard with a safe boot button. Because I have a bunch of other Gigabyte motherboards, but they don't have safe boot buttons. I don't really feel like dealing with that. So yeah, like that button makes life so much easier, especially because this memory configuration, I think it's a combination of it being dual rank and also using an old PCB layout. The memory controller really doesn't like booting this on its own. Like if you clear the CMOS, this memory configuration takes a while to like retrain and start up. So the safe, and for whatever reason, the safe mode button gets around that. So yeah, safe mode, super helpful. Super helpful for this. Um, Best feature to ever be added to a motherboard. We need it on more motherboards, along with postcodes. Because the postcode is what tells you when you need to hit the safe boot button, and the safe boot button then makes your life very easy. So yeah, and we're on BIOS version F3. So yeah, that's today's novelty memory overclock. I really enjoyed setting this up. Like this is really like this stuff is so much nicer to work with than other memory chips because you just throw it into a system. You punch in timings that are basically as low as they go. And then it's stable as long as you just mash enough voltage into it. Whereas with a lot of other, like if you try to do this with some Samsung B-die kits, some of them will just not run stable at really high voltages. Like I have Samsung B-die sticks that, you try to run them at say 1.5 volts, it's unstable. You give them 1.55 volts, it's more unstable. And then it keeps getting worse and worse and worse as you keep adding voltage. Whereas this stuff, I've not had an E-die stick roll over. You can just keep adding voltage and it just keeps going. So yeah, I love this stuff because it's just like unfortunately it is low capacity, but as far as like overclocking behavior, this stuff is awesome. It's also a shame that it only really comes in A0 PCBs. It would be much better if you could get it in A2 because then you could actually run proper like high frequencies on it. But yeah, well, like A0 is still good to up to around like 42, like 4000, 4266, or even 4400. Though it starts being really difficult, especially if you're trying to run 4 of these sticks at the same time. So, yeah, hopefully you found this somewhat interesting, because, novelty memory overclocking. Like, this was just really fun to set up. Like, I wanted to know, is it, like, there might be other, I think Micron, it might be possible to do something like this on Micron sticks. Except the main difference I feel like you would run into doing that is you would have like your TRFC instead of being like 277 would be like 550, which is a lot worse. And your TRRD would probably look like that. At this, around this clock speed, you would probably be running like 4.616 instead of 4.416. Not that there's a huge difference between 4.616 and 4.416 in terms of performance, but yeah, the 550 TRFC is not great. And then, though, with Micron, you would probably have a TRCD advantage. Like, E-die being one of the old DDR4 memory chips, really, the TRCD is quite bad. That is probably that is actually this memory chip's biggest weakness, is like, it's, for the most part, it's very similar to Samsung B-die, except, like, better behaved as far as I'm concerned, way easier to stabilize. I'm not sure that it's necessarily lighter on the memory controller. It might even be heavier, but that could also just be the A0 PCBs doing that. But the TRCD on this stuff is terrible. It could also be that the TRCD just makes this easier to run, because TRCD as a timing in and of itself is really hard on the memory controller. So running low TRCD is a lot of the time actually more about the CPU than a memory kit, but yeah. So this was really fun. Like, to set up. Like, I'm still I'm not that surprised that memtest ran, because, like, that was the whole, like, basically, I was like, I'm pretty, like, I bet I can do 3600 CL12 stable on E-die if I just give it enough voltage. Well, the answer to that question is yes. Yes, I can. So, yeah. Fun little novelty memory chip at this point, because Samsung doesn't make it anymore, and the only way you're getting it is like secondhand kits on eBay. And unfortunately, like, the crazy thing is, you can also, like, even the OEM sticks of E-die, like the green, like Samsung manufactured E-die sticks, are pretty good. They're not this, like, they're worse than this. They'll usually have like a worse TRCD, worse cast latency as well, usually like 1 or 2 ticks worse for the same speed. But they're still like, all of the subtimings still behave basically the same, and the voltage tolerance is the same, at least until you try running really, really high frequencies, because at high frequencies, this does actually start exhibiting that thing that B-die does, where it's like, oh, you raise the voltage, it gets less stable, except B-die does that across a much larger frequency range than E-die. And this video turned out way longer than I was planning for it to be. It was supposed to be like, oh, look, quick, silly memory overclock. Like, I spent more time shooting the video than, like, dialing this in. But that's, you know, that's why I love E-die. It's so easy to work with. Whereas with B-die, this would be impossible. Also, what's kind of fun about E-die is you can actually mix it with B-die kits. So if you want, like, a 24 gig memory setup, yeah, you can totally do that. I'm not sure why you'd want to do that. And also you'd be losing a lot of your, like, well, you'd basically be limited to running the timings that the E-die is stable at. You wouldn't be able to run the, like, the B-die timings. But there's not that much of a difference there other than the atrocious TRCD. Because, yeah, B-die at 3600 should do TRCD 15 at, like, actually, if you have really good sticks, you might be able to do TRCD 15 at, like, 1.35 volts. So yeah, like this stuff, on the other hand, well, if we reduce the voltage, the TRCD will probably get worse. Because it does scale a little bit. Yeah, so that's it for the video. Hopefully this was, I don't know, interesting, because I can't imagine this being useful. As you've probably not got a, like, you know, I don't know, like, I wouldn't run out on, you know, run out and buy myself a kit of 4 sticks of E-die to run them at 2 volts on a Z590 system. That's not a very sensible, like, decision to make, but at the same time, it's not a decision that would cost you very much, because these are 4 gig DIMMs, so they really aren't that expensive. So hopefully this was entertaining, and yeah, that's it for the video. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. So it would be much appreciated if you check that out, because both the Patreon and Teespring help out immensely with running the channel. So yeah, that's it for the video. Thanks for watching, and goodbye.